right, guys, let's jump right into it. So my name's Alexander. I work with XR at Siemens. You're probably all aware of it already. It's a multinational global company with over 300,000 employees. Revenues in excess of 60 billion, at least 2021, and present in many, many countries in the world. So what I'll be speaking about today is how to accelerate the industrial digital twin. So buildings today are faced with several challenges. We have demographic changes, new ways that we think now about the future. People and businesses, they demand a more flexible infrastructure, a more sustainable way of adapting to changes and expectations of people, with more resilience and with the greater future resilience as well. So this imposes a huge stress on how we think about space and utilize it the best way possible in the future. So we all know buildings are a critical part of emissions in the carbon cycle. As we transition to a net zero future, buildings are responsible for about 40% of global energy consumption. And so trying to reduce or somehow mitigate that is one of the challenges that we have here at Siemens. Digitalization is seen as the primary enabler for handling the challenges in buildings. So by enabling economic progress and bringing different silos together, we can actually do more with less. So that's why 75% of companies that we work with, they see digitalization as part of their process to driving down emissions in buildings. However, digitalization isn't always that simple. So to ensure future adaptability, for it to be future-proof, we have to get it right from the beginning, from the different facilities. So we have a couple of quadrants here in people flow, in layout, cybersecurity, building management, in comfort. Having to have these work from day zero, from the moment that you idealize or that you design your building to 10 years, 20 years, the full life cycle of the building down the line is a huge challenge, something that we are tackling with. They need to be connected, they need to be maintained. Most importantly, they need to be accessible from different vantage points. So we've come up with a new way to make digitalization easy, flexible, open, and scalable. So at Siemens, we have a digital transformation system in place, which involves many different portfolio items with clear customer benefits. So we're looking for easy integration with different customers can bring in their own systems and their own backends to hook into. We need to ensure flexibility, that they can actually customize it and then even code it to ensure that it works for their needs. And we need to have it as an open ecosystem so that new partners and new businesses can also join this growing ecosystem. We're also trying to achieve it as a start small and grow fast so that businesses can get the return on investment sooner rather than later. So a lot of different modularized pieces that can be commoditized as services. So essentially, what is this Siemens digital transformation? This is a comprehensive portfolio that it includes digital and IoT-enabled offerings from Siemens. We are heavily into the Internet of Things space with both components in factories, sensors around several different offices, and we have these as services offerings as well coupled with a marketplace so that customers can actually buy different offerings depending on what systems and what connectors they have at their plants and at their factories. So, working under three basic principles, this is how we more or less structured these three items. It needs to be interoperable. I've just come out of a talk that's ongoing on the main stage with Guillaume. He was telling that there will be heavy usage going forward, and this interoperability means spaces need to be open. APIs need to be flexible so that different data sources can come in and talk to each other. It needs to be flexible so that each item can be modularized and reduced as a component to work within this large system. And basically, it needs to be open source. So all of the APIs, all of the systems that we have, we're designing them as open source around certain security features, obviously deemed fit for industrial needs, enterprise needs, but they need to be open so that new partners can actually take advantage of this. And so because of these design principles, we've actually managed to make it smarter, all the journey across the smart building infrastructure. So with modularized functionalities, you have one platform that will benefit from the interoperable solutions, and you get the freedom to create your own digital needs, your own digital twin based on your own needs. If it's a plant for parts, if it's a plant for electronic parts, if it's an office, whatever it is that has different needs, you'll be able to source different components from this marketplace to fit it. So with these digital business platforms, they can bring in the capabilities from the market, integrate their OT, so the operation technologies, and their IoT devices that they already have in the smart buildings, and build a comprehensive, best-in-class system around it. This in our portfolio is known as the Building X, which is several different offerings that they're already in the market for large entities, large companies to already include in any sensors that they already have going. And it comes as a software as a service solution. So let's have a look at the day in the life of an employee in a smart building. So this is somebody that is coming to the office, probably from remote work. He will be able to book his desk from the comfort of his own home. As soon as he arrives, the parking system will know specifically from the place that he booked where he's supposed to leave his car. He could even have it charged in advance or reserve a charging station in advance. You can get seamless access to your building, so with PKI cards, already with QR codes on your smartphone, you can have already access to the areas that you're fit to work at. It will take you directly to your desk, and so we actually have several XR technologies working in conjunction with, for example, this specific site finding solution, that in AR, it will actually draw the pathway, guide you from entering point for somebody who's never used the office, who's never gone into the building, specifically, precisely to where you need to be at your desk. You can also set either in advance or at the time comfort settings, such as any HVAC offerings that are there, lighting conditions, blinders, AC. You can also, if you need to book a room for any sessions or any meetings, you can book it directly within all the same app. It will unlock that room. It will check for availability to see if it has been booked, what are the conditions, and you can schedule it for however long you need it. If during the meeting or afterwards you need any concierge service, you can order it directly as well from the app. And if you need to talk with any part of your management or find colleagues or bring in partners that are here to visit you, for example, you can also send out invites based on their location or the specific email of those colleagues. If anything does go wrong at any point during this journey, you can easily raise an issue, raise a request, report it, and get notifications in real time on how it's being resolved and which is the sector that's resolving it. And then finally, as you leave the building, there is the whole team for checkout and sanitization. They will come up to your desk, they will clean it up, make sure that it's ready for use for next employee. So all of this is made possible because of these design principles. There are different teams, there are different roles and responsibilities that come into play to actually offer this full journey, from the electric part, from the parking guys, from the security managers, from sanitization. So they all have one single source of truth to actually acknowledge what the user is doing or wants to do at any given time. And this can only be made due to this interoperability, the flexibility, the open source nature of these components, and having them as a service so that each team or each role, each different responsibility can easily pull into their own backend what they need to serve this journey. Let's look at a different use case, what we use as well for building from a building operator point of view in a smart building. So you might have report issues. So a circuit breaker that, for example, doesn't work, you can report to the operator via the app. You will be able to diagnose this remotely. So we have 3D digital twins that are created in place for visualization. They could be attached to different sensors, to different alarms, and these get tagged in real time as a user reports them. Once the issue is resolved, it will notify the customer, depending on the risk, and any action that will be taken. We also have AI capabilities that will then analyze the underlying problems to prevent this from happening in the future. And then finally, if you need to order a new part for any alarm or any sensor that has broken down, invoices or any reporting on the level of satisfaction or performance services, you can also do so through this server portal. So once again, this brings also different areas of expertise together due to the same design principles that we've just seen. So finally, I just want to give you an overview as a use case from a life of a building owner. So this from a perspective of a management type of scenario where they have different high-level teams that are working in one building. How would this day in the life of a building owner look like? This would be something like decarbonization, that they're interested in large facilities that need to have big transparency to base their decisions on big data. So from a decarbonization point of view, you might want to optimize space depending on where your users are booking their desks, where they're sitting. How will you be able to optimize that space, and what are the conditions to actually strive for hybrid working, remote working, and on-site working? So from a building operator point of view, you might also be interested in maintenance and energy optimization. How many cars did electric cars just book charging stations? How many of them are actually consuming energy? Where does it come from? We're also in the business of producing solar panels and generators, so we can easily keep tabs on how much energy at any given time we're using. From an energy monitoring point of view as well, so this will come from a real estate manager. He will be wanting to optimize costs in terms of energy consumption. And so having these different panels that can show in real time to all these different silos what is happening in terms of energy is very, very useful to take in big decisions. Also, if you're in the chief operating and sustainability manager, you might want to support commitment to ensure zero emissions and report on progress. So you'll hook into the actual team from the energy backend and have all these suggestions done from the AI on how to best reduce your energy consumption based on time of the day, time of the year, usage, etc. And so once again, because of these design principles, it used to be that all these different silos, from the workplace manager to the building operator to the real estate manager to the sustainability manager, they would probably get together every quarter or every once a month to discuss these big ideas. However, now they can do it all in real time and with a single source of truth. So these are basic KPIs, so it will help you to reduce with a positive ROI. They will be able to exceed decarbonization, achieve cost reduction targets, and future-proof for investment. All right, so I just want to go to finalize over a couple of success stories with you. So I'm leading a team within Siemens for the creation of this service called virtual tours. So we actually go out and scan locations, produce these 3D models that will essentially be used in the factories or the offices as the visualization tools for these back panels. Basically, we have around 70 users who have produced 200 scans already throughout countries such as the UK, Germany, Canada, Mexico, Argentina, Korea, etc. So many countries have started to use this. If you're familiar with the businesses within Siemens, we have smart infrastructures, we have digital industries, and these digital twins and this virtual tour service specifically is used throughout all these different departments. So we have 3 verticals here where we've seen the most usage for these type of digital twins. So in the facility management and operate vertical, this is where the factories are. We've been scanning tight areas 10 to 15 times faster than with the typical LiDAR scanner. So we're using small devices, almost handheld devices to do these scans. We've reduced risks that needed good documentation and need a long time to redo just because we can scan these spaces much faster. In the design and build phase, so we managed to reduce flights to remote location. Once we have the digital twin up and running with real-time data coming in, you can have these on-site experts not flying over every time there's a malfunction or there's an alarm. They can actually be in Germany or in Austria and help give support to a factory in Chile or in Brazil remotely just by logging into their digital twin. And then finally, we've also seen this very useful in the training and onboarding part, where I was just mentioning where you guide your user towards certain areas of the building. They can easily find the post office, the medical office, so for basically onboarding users. Very interesting use case also with the 41 Broadway in Oakland. So this basically, they've intelligently optimized their HVAC system with AI-powered strategies. So there's a system from Siemens called DVO, where we collect temperature and humidity data throughout the whole building. And the AI actually learns and responds to the changes in load. So it continually evaluates these zone-level data, and it will send you information about pressure and temperature data, so that the whole HVAC system is operating automatically. In Arvato, for example, there's another service from Siemens that just recently purchased called Comfy. So this is an app that is used to book your offices and your workstation remotely in all the conditions. So it's worked very well for them to ensure back to the office and remote working, much more flexibility for the employees to choose their hybrid model. So this has been really a big boon for the Arvato building. In Créteil, in France, so this is a multi-services that installs 1,200 smart sensors from Siemens. And there's a company called Enlightened, which controls the HQ's energy consumption. So this is also a company that's part of Siemens. The sensors are installed directly into the ceiling lights, and it has all different kinds of big data that comes streaming in through all the different rooms. So since it was installed in 2 or 3 years ago, they're hoping to reduce energy savings by 40% in the next decade. And then finally, we have also our flagship building from Siemens AG, where we inaugurated this new campus in Zug in December this year. And so this is a new building with over 1,000 workspaces, and the campus is the actual international headquarters for building technology. So this is a department within Siemens. It's one of the largest employees in Switzerland, actually. So they employ over 6,000 people there, and they used the digital twins throughout the design and build phase for efficiently and optimizing space all throughout the construction phase. So they have a digital twin that has been in place through the whole life cycle of this building. And that's it. So I hope you get a good overview of how these digital twins are used. We have several technologies in place to actually push forward with already existing sensors to actually hook them up to the own company's backends. I'll leave here my slide for context. If you want to then catch me outside for any further questions, feel free. Hope you enjoyed it.
Test, yes. Thank you, Alex, for a great presentation. We have time for Q&A right now, so any questions?
Just one general question, that for what you just presented for the digital twin for different roles, is that one single software or separate software combined? And what is the name of the software for that?
Thanks. There are actually several softwares for that. So we have, it goes through parts. We will first go out and scan the location. This will be scheduled throughout, let's say, 2-3 weeks, depending on availability. Once we have the 3D model, we then create the 3D mesh. It's available as visualization. That's usually pretty quick, probably another week or so. Then the hard part to actually then having it available is going through the pipeline of integrating all the different back-end systems. And this I couldn't give you, it's not one single system. There are several factory back-ends. They use their own different systems based on different operating systems. And so basically, we have an open source API that hook into those.
Yeah, and is there any AR part involved in this whole story? I see some kind of navigation or finding desk or is that the only one? Or
we mostly use technology. So for the creation of the digital twin, which will be this virtual representation of processes and buildings, we use mainly VR technologies and capturing services. But then once that is online, we do have then in-house developed solutions that will overlay information from your backend on your physical plant, so that when you're there physically, you can also go through the different assembly lines and see data in real time. It's more pertaining to an operations sector more than the digital twin, right? Digital twin will be something that you want to have on your desktop or at least on a client that you can access virtually. But yes, there are AR, for example, Comfy that we just saw with the guiding of the room. We have others for more industrial parts. You can bring a whole dashboard that you can view in your plant factory. And I would even suggest, if you're interested, there will be a panel on AR Twin just next in the XR enablement floor, that they will talk about HoloLayer, for example, which is an AR solution that we're also using in an industrial sense.
Thank you. And do you use a visual positioning system when you do the AR, or is it just there with like a marker-based AR, or is it like a VPS? because you have the digital twin?
We can have all three, in essence.
Okay.
Yeah. So if you haven't scanned it at all in the first place, you can go around with QR codes or markers, even stickers. But if you have already scanned it, you have the point cloud. And so no point in go around creating the world map. You can use already the point cloud as a world map that you already have.
Yeah, but do you provide a VPS for that digital twin, or you just have another provider, for instance? Do you work with another VPS provider if the digital twin is scanned?
No, we have our internal technology.
Okay. Yeah. So XR enablement, there's going to be another session about this.
Correct.
What is the time?
It's actually after this one. So
after this one, perfect.
2
p.m.
Yeah.
Okay.